Hello everyone, welcome to my YouTube channel. So, in the last class, we completed up to quantum numbers in this chapter atomic structure. So, along with the quantum number, we discussed about Bohr's atomic model of hydrogen atom, electromagnetic spectrum, Sommerfeld's atomic model. So, all these topics are covered in the last videos. And today we are going to discuss a new topic to arrange the electrons in various orbitals. We need to follow few principles. So the arrangement of electrons in various orbitals in the atom. So they are mainly follows three principles. First one is Pauli's exclusion principle. Second one is Aufbau principle, and third one is Hund's rule. So these are the three principles we have to follow to arrange the electrons in their shells, subshells and orbitals. Okay, so let us see the first one of this is Pauli's exclusion principle. Pauli's exclusion principle. So actually Pauli's exclusion principle is said that according to Pauli's exclusion principle, no two electrons in the same atom can have the same set of four quantum numbers. No two electrons in the atom, same atom, they don't have four quantum numbers. What are the four quantum numbers? Principal quantum number, azimuthal quantum number, magnetic quantum number and spin quantum number. So no four set of quantum numbers will be same for the electrons present in the same atom. So let us see example. Helium. What is the atomic number of helium? 2. So that means in helium there are two electrons are present. The two electrons must be present in the first main shell of helium. That means helium is consist of only two electrons. Those two electrons will be entered into the first main shell. Okay. In that the first electron is entered into 1s orbital, and at the same time the second electron is also entered into the same orbital. That's why its configuration can be written as 1s2. 1s2. Then the two electrons are present in this orbital. The two electrons are present and these two electrons will be represent like this. The two electrons will be represent like this. Right? If you observe the four quantum numbers for these two electrons, there will be some changes. No four quantum numbers will be same for these two electrons. So let us see. Suppose this is first electron and this is for second electron, and here it is principal quantum number. N is principal quantum number. L, this is angular momentum or azimuthal quantum number, and ML, magnetic quantum number, and MS, spin quantum number. These are the four quantum numbers. Four quantum numbers. So out of these four quantum numbers, so first let us see. Here actually in the configuration we are writing the configuration in the form of NLX method. NLX method. So here N is called as N is equal to principal quantum number. N is equal to principal quantum number. It represents the orbit or shell. It represents the shell number. And next L is equal to, here L is equal to azimuthal quantum number. It represents subshell like S subshell, P subshell, D subshell and F subshell and so on. So subshells can be represented with azimuthal quantum number. And what about X? X is equal to number of electrons present in that subshell. Number of electrons present in that subshell and main. Okay, so by this formula, n means principal quantum number. So here what is n value? 1. So we can take for both the electrons, both are present in the same main shell. So we can take it as 1 1. Okay, so then S, L value is, what is the L here? Azimuthal quantum number represents subshell. Which subshell is present here? S subshell. For S subshell, L value is 0. So L value is 0 means it is S subshell. L value is equal to 1, then it is P subshell. L is 2, it is D subshell. Already we discussed this in the last videos. Okay, so here S is present, so that's why we can take the L value as 0 for both the electrons. For both the electrons, L value will be 0. And at the same time, magnetic quantum number values. So for particular L values, the magnetic quantum number values will be taken as 2L plus 1 formula can be used. 2L plus 1 formula can be used. Here what is the L value? Already we seen about 0. So that means 2 into 0 plus 1. 0 plus 1 is equal to 1. Right? One value of M will be appear. So what is the one value? So actually M values will be started from minus L to plus L including 0. So there is only one value is here. So that's why that one value will be 0. If the values are 3, then the values can be minus 1, 0, plus 1. If it is 5, the values are minus 2, minus 1, 0, plus 1, plus 2. So like this the M values can be taken. Okay. So here only 1 is came, so that's why we can use that 0. Okay. And for 2 electrons present in the same orbital, and then what is the spin values? The electrons present in the same orbital, they don't have the same spin value. Their spin values are definitely different. So one electron is in clockwise spin and another electrons with minus 1 by 2, that means anti-clockwise spin. So the 2 electrons present in the same orbital, they have anti-parallel spins. So one is in clockwise direction and another spin is in anti-clockwise direction with minus 7. Okay, so this is about the Pauli's exclusion.